Hello, welcome to Leetcode server. Today we are going to solve 25th problem in May Leetcoding challenge, and the problem name is Uncrossed Lines. Uncrossed lines, we write the interval a and b, integers a and b, in the order they are given on two separate horizontal lines. Okay, now we may draw connecting lines, a straight line connecting two numbers ai and bj, such that ai should be equals to bj. The line we draw does not intersect any other connecting non-horizontal line this way. Okay. Note that connecting lines cannot intersect even the endpoints. Okay. Each number can only belongs to one connecting line. Alright. Return the maximum number of connecting lines we can draw in this way. Okay. So for one, I can match with this one, and there could be multiple one. In that case, I can match it with other ones as well. Okay, yeah, there could be multiple occurrence of the same number, and length is 500, 2000. Okay, all right. And anything else? The size may be different as well, or it doesn't matter actually. Size can be different. What matters is we have to match the same integer with the same one, and if we match this with this, then the 4, if it occurs in this side, we cannot match the 4 with that value because we already matched with this value. Okay, and if there is another 4, I can't match this another 4 with this 4, even they do not intersect, or maybe there is one point of intersect, but we cannot match with the same element multiple times. Okay, all right. I have to match same element. Okay. Well, it seems like this is just a simple modification, or I mean the problem statement is kind of reconfigured to make our the problem classic problem of like longest common subsequences. Yes, we have to find the subsequences of integer which should be longest one. The length should be longest. We have to print the length. Okay, this is just a reconfiguration of problem statement of longest common subsequence of two array. Okay, so I think I have already solved this problem before in April Leetcoding challenge, and I will probably put a link on the description, and that was the statement was just to given a two string, we have to match, we have to find the longest common subsequence of that two string, but here the only difference is integer, and we can solve it in using dynamic programming. What we can do is we can just assume that there are extra values or something. I mean, we can simply do the things like the maximum matching of, yeah, say matching. In this case we can use the term matching, maximum matching of the element just before the ith element. Suppose these are I values, I element, I minus 1th element with some kind of j element is something, then we have to consider two things, like if the value at I position and some j position are same, then definitely it will increase our matching definitely, and we will keep an keep a track of that matching plus whatever matching we could get from I minus 1 position and j minus 1 position. Well, if both of them I and j, I mean for each I we will be iterating over j, and for both I and j, if they are not same, then either we can take whatever the maximum matching we have just before that position, so 1 with 1, so this can be propagated to 1 2 as well. This is one case. I mean, if they are not same, we can either propagate this one, this maximum matching from I position to j minus 1 position, or we can also keep, like without taking this, we can also keep whatever matching we have from I minus 1 position ending at jth position. So we will take maximum among both of them. And for simplicity, the best case is like the matching of this element just before as we have to access j minus 1, sometimes I minus 1, so this can be, I mean, something. And I mean, if you use zero based indexing, then accessing at minus 1 indexing, or maybe handling them separately, instead of handling them separately, we can just treat all the values that was matching from this particular position, like one indexing all the values are, and maximum, I mean, matching of the elements from 0th position to all the positions. I mean, there is no any same value, so definitely 0, we will keep 0, 0 matching from 0th position to all including position. So that will be our base case, and then we will keep on doing the same thing, matching the same thing. So dynamic programming, let's solve it. We need a vector, two-dimensional vector, say dp, and we need a size of a, say n is the size of a, added size, and m is the size of b. So as we are doing one based indexing, we can simply make everything at 0 so that we will cover the base case. And let's iterate over one based indexing. We are now iterating over second array from first array, and if we found that the value at both position, so a of position can be accessed by performing -1, because we are holding them in I-1 position. If both of them are same, then dp of ij will be equal to 1 plus whatever value we have before matching I-1 with j-1. Otherwise, we will keep maximizing among two things. One, maximum matching we have so far. Oh, sorry, not one. Maximum among both of two. Maximum matching we have so far from ith position till ending till j-1 position, whatever matching we had. And another matching is whatever matching we had from I-1 position, just we ignored the ith position value with jth position value. So maximum among them, we will keep that one. Finally, we return dpf nm. Let's compile. Okay, all right, we can submit. So complexity is big O of n square. Time complexity, well, accepted, nice. So time complexity is big O of n square. As we can see, this loop goes up to nth position, and from each n values, we are accepting m values. So n by m is the time complexity, and space complexity is same, n by m. But we can optimize our space complexity as we had did before, I guess, in our previous lecture. So m will remain same. The space complexity will be big O of total big O of total size of B. Let's do initially 0 0 is everything 0 starting from 1. So what we do is we treat 0th position as 0. I mean every even position will be at row 0, and odd position row 1. Since we need only 2 rows, again we will use the same thing. I mean we have row 0, row 1, and next time, I mean here we can see we only need previous row. So currently previous row is 0, and when we are at I position, 1 position, previous row is 0, and when we reach to 2 position, previous row is 1 and current row is 0, and when we reach 3 position, the previous row is again same 0 and current row is 1. So in this way we will go through. I mean just keep on increasing, and let's the logic to make current, if it is odd to odd, and if it is even, I mean I value, if it is I value is odd, then make it odd. So that logic can be simply, this is actually row value, so we know that I modulus 2 will give us 0 if I is even. I modulus 2 will give us 0. Yes. And I modulus 2 will give us 1 if it is odd. So simply we can put I modulus 2 here. Same goes here as well. Now we need to have this thing I minus 1. We will apply the same thing. I minus 1 is a row. We will do modulus 2 and we get the same thing. Well, modulus 2. All right. And finally n will be n modulus 2 as well. Let's submit. Accepted. So now we have space complexity big O of m, and time complexity big O of n cross m. Thank you so much for watching this video. If you have any query, any suggestion, anything else you would like to say, please feel free to comment. And yes, see you in the next video. Have a nice day.